Mineralogy is a subject of geology specializing in the scientific study of the chemistry, crystal structure, and physical properties of minerals and mineralized artifacts. A mineralogist is a person who studies minerals, which technically include all naturally occurring solid substances. Mineral. A mineral is a naturally occurring homogeneous inorganic substance having distinctive physical properties and a more or less definite chemical composition.
Now, let's proceed on symmetry elements of crystallographic system.
Crystal structure. This is the orderly arrangement of atoms or group of atoms within a crystalline substance that constitute a crystal. A symmetry operation is an operation that can be performed either physically or imaginatively that result in no change in the appearance of an object. It is emphasized that in crystals, the symmetry is internal, that is in an ordered, geometrical arrangement of atoms and molecules on the crystal lattice. But since the internal symmetry is reflected in the external form of perfect crystals, we're going to concentrate on the external symmetry because this is what we can observe.
Now, let's go to the types of symmetry. Rotational symmetry, a process of rotating a crystal about an axis and repeat itself every specific angle of rotation. The axis along which the rotation is performed is an element of a symmetry referred to as a rotation axis. Example of it are 1, 2, 3, 4, and 6-fold rotation axis. 5, 7, 8, and more kind of fold are not possible in crystal. Mirror symmetry, making reflection of the object by imagining that you cut it into two equal parts. The plane of the mirror is considered as element of symmetry. The mirror plane could run either vertically or horizontally, which will produce two similar objects. It is not run diagonally because it will not reproduce back to its original step.
Center of symmetry. In this operation, lines are drawn from all points on the object through a point in the center of the object. Each line have lengths that are equidistant from the original points. When the ends of the lines are connected, the original object is reproduced invertedly from its original appearance.
Now, let's go to the physical properties of minerals. First, we have color. In opaque minerals, the color tends to be more consistent, so learning the colors associated with these minerals can be very helpful in identification. Translucent to transparent minerals have a much more varied degree of color due to the presence of trace minerals. Next, we have streak. It is the color of the mineral in powdered form. Streak shows the true color of the mineral. The streak of metallic minerals tends to appear dark because the small particles of the streak absorb the light hitting them. Non-metallic particles tend to reflect most of the light, so they appear lighter in color or almost white. Next, we have hardness. It is a measure of the mineral's resistance to scratching. Did you know that diamond is the hardest mineral and has a rating of 10? Cleavage and fracture. Cleavage refers to the way some minerals break along certain lines of weakness in their structure. It is the tendency of a mineral to be damaged among smooth planes parallel to zones of weak bonding. Then we have fracture, which describes the quality of the cleavage surface. Then we have the crystalline structure. Mineral crystals occur in various shapes and sizes. The particular shape is determined by the arrangement of the atoms, molecules, or ions that make up the crystal and how they are joined. This is called the crystal lattice. If there is no crystalline structure, it is called amorphous. Transparency or diaphaneity. It is a mineral's degree of transparency or ability to allow light to pass through it. Next, we have tenacity, which refers to a mineral's resistance to breaking, bending, or otherwise being deformed. Magnetism. It is the characteristic that allows a mineral to attract or repel other magnetic materials. Then we have luster, wherein it is the property of minerals that indicates how much the surface of a mineral reflects light. There are different types of luster. First, we have metallic, wherein the mineral is opaque and reflects light as a metal would. Then we have submetallic, wherein the mineral is opaque and dull. Here, the mineral is dark colored. Lastly, we have non-metallic. The mineral does not reflect light like a metal. Under the non-metallic luster, we have waxy, wherein the mineral looks like a paraffin or wax. Next is the vitreous, wherein the mineral looks like a broken glass. Then pearly. The mineral appears iridescent like a pearl. Then we have silky, wherein the mineral looks fibrous like silk. Then we have greasy, wherein the mineral looks like an oil on water. Then we have resinous. The mineral looks like hardened tree sap or a resin. Lastly, we have adamantine, wherein the mineral looks brilliant like a diamond. Another properties of minerals are odor and taste. Most minerals have no odor unless they are acted upon in one of the following ways. First is moistened, then heated, breathed upon, or rubbed. Then only soluble minerals have a taste, but it is very important that minerals not be placed in the mouth or on the tongue. Lastly, we have specific gravity. Specific gravity of a mineral is a comparison or ratio of the weight of the mineral to the weight of an equal amount of water. The weight of the equal amount of water is found by finding the difference between the weight of the mineral in air and the weight of the mineral in water.
Now let's go to the study of the following rock-forming minerals and their properties.
Quartz. Quartz is a chemical compound consisting of 1 part silicon and 2 parts oxygen. It is the most abundant and widely distributed mineral found at the Earth's surface. It is abundant in igneous, metamorphic, and sedimentary rocks. It is also highly resistant to both mechanical and chemical weathering. Quartz are chemically classified as silicate. They occur in virtually every color such as clear, white, gray, purple, yellow, brown, black, pink, green, and red. Their streaks are colorless, making them harder than the streak plate. They're also vitreous and transparent to translucent. They have no cleavage because they typically break with a conchoidal fracture. The quartz hardness is 7 and its specific gravity is 2.6 to 2.7. Its diagnostic properties are conchoidal fracture, glassy luster, and hardness. Its crystal system is hexagonal. Its uses are in glass making, abrasive, foundry sand, hydraulic fracturing, and gemstones. Feldspar. Feldspar is the name given to a group of minerals distinguished by the presence of alumina and silica in their chemistry. It is the single most abundant mineral group on Earth. They account for an estimated 60% of exposed rocks as well as soils and clays. Feldspar are chemically classified as silicate. They usually appear as white, pink, gray, or brown, but they can also be colorless, yellow, orange, red, black, blue, or green. Their streaks are white. They are vitreous and pearly on some cleavage faces. Its diaphanity is usually translucent to opaque but rarely transparent. Its cleavage are perfect in two directions. Cleavage planes usually intersect at or close to a 90-degree angle. Its hardness is 6 to 6.5 and its specific gravity is 2.5 to 2.8. The feldspar's diagnostic properties is that it has perfect cleavage with cleavage faces usually intersecting at or close to 90 degrees and has consistent hardness, specific gravity, and pearly luster on cleavage faces. Its crystal system is triclinic or monoclinic. Crushed and powdered feldspar are important raw materials for the manufacture of plate glass, container glass, ceramic products, paints, plastics, and many other products. Augite is a rock-forming mineral of the pyroxene group commonly found within igneous and metamorphic rocks. It is a mineral of interest to geologists and collectors. While it has little to no industrial value, the presence and development of augite may help tell scientists and geologists about Earth's history in certain regions. Augite is chemically classified for having a single chain of inosilicate. Its color is usually dark green, black, or brown. Its streaks varies from white to gray to very pale green. Augite is often brittle, breaking into splintery fragments on the streak plate. This can be observed with the hand lens. Rubbing the debris with a finger produces a gritty feel with a fine white powder beneath. Augite is vitreous on cleavage and crystal faces, but dull on other surfaces. It is usually translucent to opaque but rarely transparent. Augite's cleavage is prismatic in two directions that intersect at slightly less than 90 degrees. Its hardness is 5.5 to 6 and its specific gravity is 3.2 to 3.6. The augite's diagnostic properties is that it has two cleavage directions intersecting at slightly less than 90 degrees. It has green to black color and has a specific gravity of 3.2 to 3.6. Its crystal system is monoclinic, and it has no significant commercial or industrial use. Garnets are chemically classified as silicate. They are typically red but can be orange, green, yellow, purple, black, or brown. Blue garnets are extremely rare. Garnet streak is colorless. It is also vitreous and has the diaphanity of transparent to translucent. Garnets has no cleavage. Their hardness are 6.5 to 7.5 and their specific gravity ranges from 3.5 to 4.3. The garnet's diagnostic properties are its hardness, specific gravity, isometric crystal form, and lack of cleavage. Its crystal system is isometric. It can be used as a water jet cutting granules, abrasive blasting granules, filtration granules, abrasive grits and powders, and gemstones.
Hornblende is a rock-forming mineral, a field and a classroom name used for a group of dark-colored amphibole minerals, found in many types of igneous and metamorphic rocks. It is an important constituent in acidic and intermediate igneous rock. It is chemically classified as silicate. It is usually black, dark green, and dark brown. Its streaks are white and colorless. Due to its brittleness, it often leaves cleavage debris behind instead of a streak. It is vitreous and translucent to nearly opaque. Its cleavage has two directions intersecting at 124 and 56 degrees. Its Mohs hardness is 5 to 6. Its specific gravity is 2.9 to 3.5, varies depending upon composition. Its diagnostic properties are cleavage, color, and elongate habit. Its crystal system is monoclinic, and it has a very little industrial use. Biotite is a rock-forming mineral found in a wide range of crystalline igneous rocks. It also forms under metamorphic conditions when argillaceous rocks are exposed to heat and pressure to form schist and gneiss. It is chemically classified as dark mica. It is black, dark green, and dark brown. Its streak is white to gray, where flakes often produced. Its luster is vitreous. Biotite thin sheets are transparent to translucent, and biotite books are opaque. Its cleavage are basal and perfect. Mohs hardness is 2.5 to 3 and specific gravity is 2.7 to 3.4. Its diagnostic properties are dark color and perfect cleavage. Its crystal system is monoclinic and it has a very little industrial use. Calcite is a rock-forming mineral and one of the largest carbon repositories on our planet. Some geologists consider it to be a ubiquitous mineral, one that is found everywhere, extremely common, and make up a significant portion of Earth's crust. It is principal constituent of limestone and marble. It is chemically classified as carbonate. It is usually white but also colorless, gray, red, green, blue, yellow, brown, and orange. Its streak is white and luster is vitreous. Calcite's diaphanity is transparent to translucent. Its cleavage are perfect, rhombohedral, and 3 directions. Its Mohs hardness is 3 and specific gravity is 2.7. Its diagnostic properties is rhombohedral cleavage, powdered form effervesces weakly in dilute hydrochloride, curved crystal faces, and frequent twinning. Its crystal system is hexagonal, and it is used as acid neutralization, a low hardness abrasive, soil conditioner, and heated for the production of lime. Muscovite is the most common mineral of the mica family, an important rock-forming mineral present in all types of rocks. It is chemically classified as silicate. Muscovite thick specimens often appear to be black, brown, or silver in color. However, when split into thin sheets, muscovite is colorless, sometimes with a tint of brown, yellow, green, or rose. Its streak is white and often sheds tiny flakes. Its luster is pearly to vitreous, and muscovite diaphanity is transparent to translucent. Its cleavage is perfect. Its Mohs hardness is 2.5 to 3, and specific gravity is 2.8 to 2.9. Its diagnostic properties are cleavage, color, and transparency. Its crystal system is monoclinic, and it is used in manufacturing of paint, joint compound, plastics rubber, asphalt roofing, cosmetics, and drilling mud.
Let's proceed to the process of formation of all minerals. We have 4 main categories of mineral formation. Number 1. Igneous or magmatic, in which minerals crystallize from a melt. Second, sedimentary, in which minerals are the result of sedimentation, a process whose raw materials are particles from other rocks that have undergone weathering or erosion. The third one is metamorphic, in which new minerals form at the expense of earlier ones owing to the effects of changing, usually increasing temperature or pressure, or both on some existing rock type. Fourth, hydrothermal essentially means hot water. Hydrothermal rocks are those rocks whose minerals crystallize from hot water or whose minerals have been altered by hot water passing through them. Many hydrothermal rocks, such as those that form from hot springs and geysers or crystallize as veins and cracks in other rocks, actually build up in layers much as sedimentary rocks do.
Hi engineers! We can see many vehicles like bikes, cars, and trains all running around us. But they don't need any food for them to function. Where do they get their energy? They get their energy from fuel, which can either be coal and petroleum products. Coal. Coal is a hard like stone and black in color, which can be burned as fossil fuel. This fossil fuel is found in the form of sedimentary rocks and is often known as black gold. Thus, it fulfills almost 67% of the total commercial energy in India. Coal can be classified on the basis of carbon content and time period. Anthracite is the best quality of coal, which carries 80 to 95% carbon content. It ignites slowly with a blue flame and it has the highest calorific value. In India, it is found in small quantity in Jammu and Kashmir. Bituminous carries 60 to 80% of carbon content and a low level of moisture. It is widely used and has high calorific value. In India, it is found in Jharkhand, West Bengal, Odisha, Chhattisgarh, and Madhya Pradesh. Lignite is often brown in color. It carries 40 to 55% carbon content and it has high moisture content, so it gives smoke when burnt. In India, it is found in Rajasthan, Lakhimpur, and Tamil Nadu. Peat has less than 40% carbon content and it is the first stage of transformation from wood to coal. It has low calorific value and burns like wood.
Gondwana coal. Around 98% of India's total coal reserves are from Gondwana times. This coal was formed about 250 million years ago. Tertiary coal is of younger age. It was formed from 15 to 60 million years ago.
According to GSI, CMPDI, SCCL, and MECL, a cumulative total of 319.02 billion tons of geological resources of coal have so far been estimated in the country. Based on the results of regional and promotional exploration, which carried out up to 1,200 meters of depth, where the boreholes are normally placed 1 to 2 km apart, the resources are classified into indicated or inferred category.
Petroleum.
Petroleum has been derived from two Latin words, petra, meaning rock, and oleum, meaning oil. Thus, petroleum is oil obtained from rocks, meaning it is also called mineral oil. Petroleum is an inflammable liquid that is composed of hydrocarbons and the remaining is chiefly organic compounds. Petroleum and petroleum products are mainly used as motive power. It is a compact and convenient liquid fuel which has revolutionized transportation on land, in the air, and on water. Petroleum has an organic origin and is found in sedimentary basins, shallow depressions, and in the seas. The decomposition of organic matter in the sedimentary rocks has led to the formation of oil. As the organisms die, their bodies settled at the bottom of the sea and was covered with sand and clay. After millions of years, they are subjected to high pressure and temperature, which formed into petroleum and natural gas. An oil reservoir must have three conditions. Number 1, porosity so as to accommodate sufficiently large amounts of oil. Number 2, permeability to discharge oil or gas when well has been drilled. Number 3, there should be an impervious beds to contain the oil. India has vast areas covered by sedimentary rocks that contains oil. According to the Indian Mineral Yearbook, it estimated a reserve of 468 million tons, of which 328 million tons was available in Mumbai. India was a very insignificant producer of petroleum at the time of independence. In fact, offshore production did not start till the mid-1970s, and the entire production was received from onshore oil fields. In 1980 to 1981, about half of the production of crude oil came from onshore fields, while the remaining half was received from the offshore resources.